In this problem, we're trying to find the net force on one of the charges. In this case, it's charge 2. So we first look at charge 1 and charge 2 and see that they are opposites. 1 is a positive, 2 is a negative, so they will attract each other. So the force from charge 1 will be to the left. Charge 3 and charge 2 are both negatives. They will repel each other. So the force from charge 3 will be straight up. Charge 4 is a positive, so that also will attract charge 2. So that force will be on an angle. So what we've got now are 3 forces that we need to calculate. We can calculate each individual force pretty easily. We calculate the force from charge 1 by doing Cc, Coulomb's constant, 9e to the 9th, charge 1, charge 2, and radius squared. For the radius, we're going to use the distance from charge 1 to charge 2, which is 40.7 centimeters. Make sure you work it in meters. Once you get that force, you could then calculate force 3. Use charge 3 and charge 2 as your two charges. Use the distance between them as 23.2 centimeters. Remember to put your distance into meters and your charges changing from microcoulombs to regular coulombs. For charge 4, it's a little trickier. Charge 4, we do not have the direct distance, so we need to make a hypotenuse. And we use our two legs, 46 centimeters and 23 centimeters, to find the distance between charge 2 and charge 4. Okay, once we have all of our forces, we have to break up the force between charge 2 and charge 4. Because that force is being pulled on an angle, we need to break it up into a horizontal part and a vertical part. We get the angle by using the distance triangle we worked with earlier, where 46 is one leg, 46.7, and 23.2 is the other leg. We use our trig and find our angle. That should be the same angle we have here. So take the force that you found from charge 4, break it up into an x part and a y part. Now we have to decide if we're going to add or subtract. So since charge 1 and charge 4 are both pulling to the left, we're going to add those to get the total force to the left. For charge 3, that's pushing up. Charge 4 is pulling down. They're in opposite directions, so we subtract. We then take our total x force, our total y force, and we combine them into a triangle to find the net force on an angle. So you get the value of the hypotenuse and the angle from trigonometry, and that will be your net force on charge 2.